Hello students, welcome everyone, welcome to your favorite channel Vedantu NCERT Solution. In this channel you will get a detailed solutions of each and every question of your NCERT, and it will be explained in a simple and easy way so that you can understand and score more in your examinations. Now in this session let us try to learn and solve 14th question of your exercise 1.1. Let us try to read the question and understand first. Let L be the set of all lines in XY plane and R be the relation in L defined as. R is a relation which is defined as L1 is parallel to L2. Show that R is an equivalence relation. Find the set of all lines related to the line Y is equal to 2x plus 4. So we have to find a set of all lines related to the line y is equal to 2x plus 4, and this is the second part of the question. Let us keep it as it is. Let us try to solve the first part. They have given a relation where L1 is parallel to L2. They have given a relation L1 is parallel to L2. Now if you notice this, children, just observe. Let us try to think about a reflexive relation. Okay, now always a line, any line you take, it will be parallel to itself, correct? If L1 is parallel to L2, L1 only you consider. L1 is parallel to L1 only. Yes children, yes, I can write L1 parallel to L1. Yes or no? Yes, possible. If L1 is parallel to L1, can I call this can be reflexive, children? Yes, always. If L1 comma L2 belongs to R is a relation where L1 and L2 are parallel to each other, then L1 comma L1 is also true. Yes, a line will be parallel to itself, will be parallel to itself, right children? A line will be parallel to itself. So what we write, it is reflexive, right children? It is a reflexive relation, right? You take any line, it will be parallel to itself when you're comparing. Yes. Now let us try to check for symmetric. If you have two lines, think you have two lines L1 and L2. If L1 comma L2, children, if L1 comma L2 belongs to R, that means L1 and L2 are parallel to each other. In that case, if L2 comma L3, you have three lines L2 comma L3. So let us not take L3 now, let us take L1 and L2 only, because we are just proving for symmetric, right children? So L1 comma L2 we have proved. You know that L1 comma L2 means L1 and L2 are parallel to each other. Then L2 comma L1 is also true, children, right? Consider two lines, observe two lines. If suppose I take these two lines, these are parallel, I call these are parallel. If L1 is parallel to L2, then L2 should be parallel to L1. Yes, so in that case it is symmetric. What is the reason, children? A line parallel to another line will be parallel to both, correct? They are mutually parallel to each other, correct? Right children? Yes, same holds good when you talk about perpendicularity also. If L1 is perpendicular to L2, L2 will be perpendicular to L1. Similarly here, so it is a symmetric relation, right? I hope this is clear for all my students. Easy and simple. Yes, you can write a statement. If L1 is parallel to L2, then L2 should be parallel to L1, right? Simple and easy. Now let us try for transitive, having three lines L1, L2, L3. Let us try for transitive. So is it transitive relation, children? Think and tell me. If we have three lines, suppose take an example, we have three lines, okay? L1, L2, L3, okay? If we write that, try to understand this. If we have a line L1, this is parallel to line L2, and this is parallel to line L3. Just observe L1, L2, L3. If L1 is parallel to L2 and L2 is parallel to L3, then L1 should be parallel to L3, right children? True. So we can write if L1 comma L2 belongs to R and L2 comma L3 belongs to R, then L1 comma L3 also should belong to R, children. True. because if L1 is parallel to L2, then L2 should be, if L2 is parallel to L3, then L1 should be parallel to L3. Children, true, very true. Look at this. Yes, so what do you write? It is a transitive relation. It is a transitive relation. If it is a transitive relation, children, try to understand. If it is a transitive relation, then what do we write? It is symmetric, correct? Since R is reflexive, symmetric, and transitive. R is reflexive, symmetric, and transitive. It is an equivalence relation. It is an equivalence relation. Yes, children, true. It is an equivalence relation, right? No, it is an equivalence relation. So here, the parallel case, if two lines, if the relation is given as L1, L2 parallel to each other, in that case it is reflexive, symmetric, and transitive. Now let us try to understand the third or the sub question given here. I consider it as the last question given in the question, or you can call it a sub question given along with the question. Now try to understand this, children. In this, they're telling you that the given line 2x plus 4, you need to find R, or you need to find set of all lines which is related to the line 2x plus 4. And if you're talking about the relation, we are talking about parallel condition. You know, parallel lines have the same slope. And slope of this line, what is the slope of this line, children? Y is equal to mx plus c. If you compare, slope of this line m is 2. So in that case, any line parallel to this will be of the form 2x plus c, because the y-intercept will be different, because c is the y-intercept, but the slope will remain same. So any line parallel to line y is equal to 2x plus 4 will be of the form y is equal to 2x plus c. Is that clear? So what do we write? Tell me, what do we write? If we are proving this relation, yes, if we are proving this relation, or if you are writing about this relation, you can write line y is equal to 2x plus 4 has slope m is equal to 2. So any line parallel to this line will be of the form, what will be the form, children? Will be of the form 2x plus c, because it will not be 2x plus 4, because y-intercept will be different, whereas the slope will remain same. So we can write 2x plus c. Is that clear, children? Any line which is parallel to the line y is equal to 2x plus 4 will be of the form 2x plus c, because both will have same slope, but its y-intercept will be different. I hope this is clear for all of you, children. Easy and interesting problems. Like, share and subscribe. Share it with all your friends so that you can understand these questions and your friends also can solve to score more in your examination. Thank you, students.